the ability to run Code RealTime in a web browser on the web. So this is part of a new platform or product called DevOps Automation, which actually contains not only Code RealTime, but many other tools that are related to software development. So you have planning tools for creating work items and managing projects. You have control for managing source code in Git repositories. There are tools for doing testing, measuring the effectiveness of your development, planning a release, and etc., and deployment also. And this last tile here, code, is where you actually are doing the development, where Code RealTime is part of. So when you click on this button, it will take a few seconds, and what happens now is that it launches a dev container. So this is a Kubernetes environment where every user that logs into code gets his own personal development environment, which we call dev container. And in that dev container, we have pre-installed all the tools you need for development. And in this first version, we have we do it always like this. So it's C++ development using Code RealTime and CLangD. There is an extension which we call DevOps Code, which provides some integration with other tools that you saw on that first page. And there is a Java support. In the future versions, this will be possible to customize so that you can more fine-grained specify, I want this C++ compiler, I want that Python, for example, or whatever other tool you use or language you use when you are developing. So what also happened here is that this Code RealTime got activated. I have actually already imported all the samples that is in the public Git repository for Code RealTime and open them here in my workspace. And if we just take one of them, like ping pong, for example, you see it looks exactly as if you would run it on your desktop. This is actually VS Code that is embedded here in a web browser. And we can open diagrams just like we can in desktop version. So let's open a structure diagram. We get it here, and from here, for example, we can open a state diagram of the pinger capsule like this. And if we want to build it, we do just like we do on desktop, right click and do build. And here you see that G++ is already available. So one of the benefits with this is that you don't have to install anything. You get everything automatically installed for you. And finally, we can run the sample just like we would do locally. So you basically have your own file system and your own tools here, and you can work with this just like you could do locally. And then when you're done, of course, you need to go here and push your changes to Git so that others in your team can see them. And then good practice, probably when you go home for the day, you go here and do log out, and then you get the option, do you want to let this development environment keep running or terminate it? So if you terminate it, all your local files that you didn't push to Git will be lost. But that's typically good to do to save resources in your cluster, especially if you're going to not work on this in a while. But if you're planning to come back soon again, you can just click this no let it run, which means that it's now still running, and next time you log in, it will go much faster. So this is a brief introduction to DevOps Automation. I think you will hear more about it later. Any questions on this?
If you want to use cross compilers, how would you do that?
Yeah, so this is based on an Ubuntu underlying image. So if there is a cross compiler available, I guess you could run it just like you would have done otherwise. But if you need the code to be built somewhere else, where a compiler, let's say you don't have a cross compiler available for Ubuntu, but you have it on some other system, then I guess you would need to check out the files and build them there.
So one has access to install, say, not from the normal package mechanism of Ubuntu, but say one wants to install from the ARM compiler site, if one wanted to install Ubuntu compilers there, because they do have cross compilers that run on Ubuntu. One could do that.
Yeah, so like I said, in the first version here, the content of this dev container is hard-coded. So in this first version, you cannot do it.
Understood. Okay.
But later we are going to base this on a standard called dev containers.json, which is something that I think Microsoft originally came up with, and that many IDEs now support. And it basically is a JSON file that describes what Docker image do I want to have, what additional tools should be installed, and then all that things happen when the dev container launches. And then you can do basically anything, like installing your own tools or compilers of the exact version you need. So, but that is, I guess, what is needed so that you can fully configure how this should look.
Right. That sounds good.
Any other questions?